Hi everyone, today we're going to be talking about how to name binary ionic compounds. We're going to start off with aluminum and sulfur. And I know at this point you should be quite familiar with how to use Lewis dot diagrams. And so I'm going to show you how to get to the formula by using the Lewis structures. Now we know that aluminum has 3 valence electrons and sulfur has 6. So when I take a look, we know that aluminum is the metal and it will give up its electrons to the sulfur, which is the nonmetal. And in doing so, we see that the transfer always goes to the unpaired location. And I'll just mark that with an X. So I can see that sulfur is capable of picking up 2 electrons and it's fulfilled its octet. However, aluminum still has 1 valence electron to donate, and we have to bring in another sulfur in order to pick up that valence electron. So I will bring another sulfur in with its 6 valence electrons, and I will see that this aluminum can then donate. Now we notice that this aluminum is now content, same with this sulfur. This sulfur is still unfulfilled. What we need to do is we need to bring in another aluminum, and we continue this process until all of our octets are satisfied. So aluminum now has been brought in and it can donate. So we have 2 satisfied sulfurs, 1 aluminum, and another aluminum that has its 2 valence electrons that still needs to give up. So we bring in another sulfur, and I'm hoping at this point we can see that everybody has fulfilled that requirement. Perfect. Now, when aluminum gave up its 3 electrons, it acquires a +3 charge, becoming a cation, and so does this aluminum. Each sulfur picked up 2 electrons, electrons being negative. So this sulfur has a -2 charge, becoming an anion, -2 and -2. Now, if we've done everything properly, we should notice that the net negative charge, which is -6, and the net positive charge should equal so that we have a compound that will be neutral. So we are on the right track. Now, this, we can take a look and we can see that it took 2 aluminum and it took 3 sulfur in order to make this work. So the formula would be Al2S3, 2 aluminums and 3 sulfurs. Now, this is a lot of work to always do to try and figure out the formula. What we can do is we can use what's known as the crisscross method. What you do is you start off with your metal and your nonmetal, the symbol for each, and you write them side by side. And we go and take a look at the valence of aluminum, and we say, oh, aluminum tends to give up 3 electrons. So I put a +3 above its symbol, and we notice that sulfur tends to pick up 2, and I put a -2 above. What we then do is we use those charges and we do what's called a crisscross. The charge of the anion becomes a subscript of the cation and vice versa. So when I cross those out, what we end up getting is Al2S3, which is the same as what we have above. In terms of how to name binary ionic compounds, and this works for when the first element only has 1 valence option, we keep the name of the first element the same. So we call this aluminum. And the name of the second element, we change from sulfur to sulfide. So the ending becomes IDE. Some spelling of sulfur is with an F, that is the American version. I will keep it with the PH. So aluminum sulfide. If I was to do another one for you with calcium and oxygen, I go and I take a look at the periodic table, and I notice that calcium only has 1 valence option, and it has a charge of +2. Metal written first, non-metal written second. Oxygen is always a -2. It's looking to pick up 2. When I crisscross, I notice the formula here will become Ca2O2. Now, whenever you have a subscript where it is divisible by a lower common factor, you must do that. So 2 goes into 2, 2 goes into 2, and so we will reduce that to CaO. When there is no number written, it's assumed that there is a 1. You never write a 1 as a subscript. It's always assumed. How do you name this? Well, you keep the name of the first element as is, calcium, and you change the ending of the second element to "ide." So this would become calcium oxide. And there you have it.